Video, we're going to explore the idea of a binomial expansion and how we can use it when we're looking at terms of an expansion or a product of two binomials. So, the first question says the first three terms in ascending powers of x of a binomial expansion 2 minus 3x to the power 6 are 64 minus 576x plus 2160x squared. This was something that would have been answered in the part A of a previous question. The bit that we were struggling with in lesson was this part B section, which is hence or otherwise find the first three terms in ascending power of x of an expansion. Now, there are two ways they ask this. They could ask you to find a particular term with the coefficients, or finding a general series and find the first few terms. So, how are we going to do this? Well, in part A, we've already found the first three terms of that binomial expansion 2 minus 3x to the power 6. So what I know is if I have 1 plus x over 2, and then instead of writing out 2 minus 3x to the power 6, I just fill in the terms that I already know. So 64, take away 576x plus 2160x squared. I also have some other terms, however, that is my expansion written out. I want to find the first three terms. Well, this is going to be a product of the two things, and then if I just want the first three terms, I'm going to have a constant term, a linear term, and a quadratic term. So I only need to go up to the powers of x squared. So how do I do that? Well, I'm just going to multiply through. So 1 multiplied by 64 is 64. Going through again, x over 2 multiplied by 64 is going to give me plus 32x. Because again, remember, I'm multiplying by the x. Then I do the same thing again. I just look at 1 multiplied by negative 576 and x over 2 multiplied by negative 576. So doing that, that's going to give me subtract 576x plus, and what's that going to be? Well, sorry, not plus. It's going to be subtract again, but this time it's going to be something x squared. Well, half of 576 is 288x squared. And finally, the next thing, 1 and multiplied by that already quadratic term. And I'm going to put plus 2160x squared. Now, I don't need to actually work out any other terms. The reason for that is because if I went to work out x over 2 multiplied by 2160x squared, that would give me a cubic term. So all I need to do is focus on simplifying these terms a little bit further. So I know that this is equal to 64. 576 and 32 is going to give me subtract 544x. And then negative 288 and 2160. All I'm going to do is just 2160 and take away 288. And that gives me 1872x squared. So that's it for the first question. So the next question, we're going to look at how we can do all of this in terms of how is it asked in an exam. So the question reads, find the first four terms in ascending powers of x of the binomial expansion 1 minus 2x to the 5. So that's going to be my first job. And then if x is small, so that x squared and higher powers can be ignored, and we looked at that in the lesson, show that this expansion is approximately equal to 1 minus 9x. So, first step, find the first four terms. So, the power is 5, so therefore when I'm looking at working out each term, it's going to be 5 choose 0, 5 choose 1, 5 choose 2, 5 choose 3. That would be my first four terms. Now, looking at my powers of x, well, x is negative 2x, so I'm going to multiply by negative 2x to the 0, negative 2x to the 1, negative 2x to the 2, and finally negative 2x to the 3. And then finally, what happens with my other value? My other value is 1, and the powers are going to go, well, 0, so it must be 5 times 1 to the 4, 1 cubed, and 1 squared. And hopefully we understand that it doesn't really matter if my constant term is just a 1, because that's always going to be 1. So the first value is just a 1. 5 choose 1 is 5. Multiplied by negative 2 is going to give me negative 10x. And then I think it goes 1, 5, 10. So 10, negative 2 squared is positive 4. So this is 40x squared. And finally, what's the next term going to be? Well, I think this is going to go back to 10 again, isn't it? So 10 and then 8, so it's a negative 80x cubed. So one thing we need to remember, and I tried to stress this in the lesson, it's always useful to actually write this series as a whole series. So underneath, I'm just going to write down 1 subtract 2x, and this is to the power of 5, and because I only have a first 4 terms, I'm just going to put approximately equal to, because it's not exact, but it would be 1 minus 10x plus 40x squared minus 80x cubed. And there is other terms. If you put an equal sign, you could denote it with some dots. And then we're going to look at part B. Part B says if x is small, so that x squared and higher powers can be ignored, show that this is roughly equal to 1 minus 9x. So what that means then? Well, x is small, so therefore if I'm going to put these two things together and I'm going to get something which is bigger than x squared, I don't need to include it. So really all I'm doing is just thinking about this as some form of quadratic. Well, 1 minus 2x to the 5, I already know, I'm sorry, I'm just going to do some work out like down here. I get 1 minus 2x to the 5 and 1 plus x. I know that this 1 minus 2x to the 5, like I could do before, I could rewrite it as 1 plus x, and then instead of 1 minus 2x, it can be 1 minus 10x plus 40x squared, and so on. I don't need to carry on any terms because I know that I'm going to ignore any terms bigger than x squared. So let's do my expansion. 1 times 1 gives me 1. X times 1 gives me x. And 1 times negative 10x is going to give me negative 10x. And then if I carried on and looked at x multiplied by negative 10x, that's going to give me an x squared term, which obviously, like I said earlier, we don't need. So all I need to do is rewrite this as 1 minus 9x. And therefore, I can say that this expansion up to the powers of x squared is approximately equal to 1 minus 9x as required. So, what I'd like you to do in your own time is have a look at this question in the yellow box in the bottom left corner, and it's a show that question, so hopefully you should get an answer with a coefficient of negative 384 for part B. Thank you for watching, and I hope to see you in the next video.